Hi all, just a quick video about how to get stream tables out of Aspen and into LaTeX. So we'll assume that you've got a process flow diagram completed here. I'm just borrowing the one from homework 1, so we'll make a couple of modifications as we go, and that you've run it and it's converged and all of that good stuff. So over in results summary, under streams, will be the full stream table of all of the streams for all of the properties, which is way too many. So we're going to trim this down and get it into a nice format that plays well with LaTeX. The format I'm going to use is copied off of this one from Turton. So we're going to get close to what they show here with stream numbers along the top, some basic information, temperature, pressure, mole fraction, etc. on the top, in the first few rows, and then component flow rates underneath that. So we'll see small variations on each one of these, but we'll practice the big elements of that. In LaTeX already, I've got this sample document, which is just a simple illustrative document that has a bunch of blank text in it. We have used the book tabs package, which if you're using the 176 template is already loaded. Lipsum gives us the fake text. CleverRef allows us to label things the way I want. SIUnitX, we're going to put some units in there, and Sticks2 just changes the typeface. The geometry is being used to set the margins. Again, most of that is already included in the 176 preamble, so you shouldn't need to add that. First thing we're going to do is copy this out of Aspen by clicking in the top left corner, then right-clicking, saying copy all, and we'll go over here into Excel, paste everything. Sometimes it pastes with formatting. You can see it got everything we want. We're going to spread out column A just so we can see everything. The information that we want are, of course, the streams up here, which we're going to change. We can also make modifications like here to note that stream R doesn't actually exist. There's nothing in stream R, so we can delete that. And then we collect the information we want. So we need some temperatures and pressures, which are going to be here and here. We also want the molar vapor fraction, which is going to be here. We want the various flows. So we want the total molar flow rate, which is here, the component molar flow rates, which are here, as well as the mass. And this one, for simplicity, we're just taking the total mass flow rate. And we can include other things like enthalpies and whatnot as you see fit. We'll see how to do that here in a moment. So let's just collect all of these over somewhere where we can quickly access them. So we'll grab all of our molar flows over here as well. Let's not forget our vapor fraction. We already have the total molar, and now we just need the total mass as well. So that one's going to go here, and then this one will go up here, and then we want the word component flow here, which I'm just going to abbreviate as COMFLOW right now. So let's remove the bold, since we don't need any of the bold. We don't need any of these extra units here. We're going to put all of those into our first column over here. So let's just do that really quick. Temperature is degrees C. I actually don't want that right now. I want this. Pressure is in bar. Molar vapor fraction we'll leave the way that it is. Mole flows, those are kilomole per hour. Mass flows were kilogram per hour. And now here in component flow, we're going to, we don't need to exit, put that in there. We can put that flow up here in the top as they did over in the other one. And then we just decapitalize all of these. So methane, hydrogen, nitrogen, ammonia. I actually prefer them not to be capitalized at all. I understand the argument for doing it because it's the beginning of the table, but I prefer them to all be lowercase. And the rest of that we can deal with as we go. The other thing, these should just be numbers. So if you have labeled them as letters, remember streams should always be numbers. The last thing we want to do is fix the decimals because we have a variety of different decimals of precision. It can change throughout the table, but it should be consistent for things like flows. So let's copy paste this from here to here. And all of these that I've highlighted here, we want to round those to, let's say, 1 decimal point. So we delete them all, and we say round, point up to the one above it, and say 1 decimal. Right, and then we can copy these everywhere we go. Make sure that it's actually showing the correct number of decimals by adjusting the decimal point up here in the ribbon. And then, of course, this middle row here doesn't actually need any numbers. The temperature and everything else seems to be more or less the way that we want it. So this is very close to what we want, right? We've done all the major effort of trimming everything down. So I'm going to highlight everything that's on here. I'm going to copy it. And then we're going to use a tool online that you can find, which is at tablesgenerator.com. Tables is plural. You come into a page like this. It may ask you for access to your clipboard. I will paste the table here. And you can see it mostly works. Sometimes you have to readjust things a little bit. So for example, there, the numbers didn't work out quite right. So 1, 2, 3, 4, 5, and 6. Don't enter right there. Everything else more or less seems like it's the way that I want. The alignment is a little bit odd, so we want to take all of these and align them to the right. We want all of these and have those aligned to the left. And then for the most part, I'm okay with everything else that's on here. That does the heavy lifting, right? We then click generate and we get this table down here and we copy it out of this tablesgenerator.com and we go over into LaTeX, paste it here. I'm just going to adjust the tabular environment over there by moving it over a little bit, and we recompile, and we should have the beginnings of our table down here. And the last thing that we need to do is just sort of mess around with some of the formatting. So the first thing that we want to do is, of course, add our caption. So the caption goes at the top. So we'll say caption my stream table. You will probably want to refer to it. So we're going, or cross-reference it. So we're going to give it a label, and we'll just call it stream table. Remember, those go up on the top. Within the tabular environment, we only want a few lines. We want a top rule at the very beginning. We want a mid rule here. So we increase the rule there. And then we want a bottom rule down here. To do that, sometimes you have to add the extra double backslash on the very bottom. And we say bottom rule down here. And we'll check that because sometimes you don't need that. So I don't often remember which one is which. The other thing that I want to do is I want to turn this bold because that was bold over in Turton, right? They put bold right here. I'm not going to turn these numbers up here bold, but we could. There wouldn't be anything wrong with, well, I don't know. It would look a little bit weird doing something like that. I'm going to extend this and say component flow as kilomole per hour. I'm okay with these units. I just want this one to show up as an actual degree C. So I'll say unit/Celsius, like that. And then we'll go ahead. And the last thing I always forget, when you come up here to the very top of the table, type /centering, because you'll notice right now the table is not centered on the page, right? It's over on the left. We want it centered left and right. So let's go ahead and compile that. Oh, I misspelled Celsius. Celsius. There we go. Compile that again. And there we go. We have a nice simple stream table with a caption on it. More or less looks the same way that Turton's example did over here. We can add, I like this little indent that they've added over here. So we can add that as well. There's a function in LaTeX called hspace, and we can bump it over by the width of 1em. And an em is generally the width of the capital letter M in the typeface that you're using. So we can add that on there, and you can see now it has bumped over our flows a little bit. Again, I would be okay if those are capitalized or not. It's sort of up to you in that case. But you can see all of our numbers are aligned right, and all of our column labels over here, or row labels over here, are aligned left. And we've got ourselves a table. So hope that was useful for you. Good luck with everything, and let me know if you have any questions. Bye all.